The Electron. It's pretty round, but where the heck does it get its mass from? I don't know. Nuts. Vortices. The ether. Well, you all know what that means. We conjecture ahead.
This is going to be weird, and it's going to be about a different.
Title of the conference was something like "Ground Truth" or "Turtles All the Way Down," and so it seems as though there's one Ruliad. I don't think it rules them all, and it might be just hyper-rulial turtles all the way down.
Yes, it's on the back of an infinite number of hyper-rulial turtles.
Various people are commenting on the outrage of hacking the universe on a MacBook Air.
Yes, we're back, and I have a crazy equation. I know what you're saying. Memes, you've done this before. That is correct. I totally have. But we have an updated poster, and essentially, we'll go over to our friend the chemistry poster. Where is our friend the chemistry poster? Okay. Basically, in order to do the first thing, well, embiggen it. You've been embiggened, my friend. All right. So to go through this 288 things, yeah, there's a lot of data points on here. Yeah. If I want to do it accurately, if that's what I'm going to claim, yeah, I actually need to do the mass of the electron, and we should have it updated to the best of our knowledge. So in order to do all that stuff, I need to, where's our mark? I need to start here. What is here? All right. Thank you, my friend. Quick preview. Alrighty then. We go back to our other crazy window here. All right. Crazy window. Here we go. And it keeps on. How long have I been muted for? Have I even been talking any of this time? It's okay. It's okay. These things happen. So, what the heck is this? The heck is this? We're using our universal binomial factorization equation right here. All right, so calculate the mass of the electron. Basically, you set it equal to our data points, and we do our best fit. This hits it pretty dang well. Maybe a little too well. We shall see. So what's the claim here? All right, the claim is we have mass of the electron. We have our primary action right here times our dimensional boundaries. The primary action is 4 Giesecke constants. Also equivalent to 2 of the values of the hyperbolic figure 8 knots complement per volume. We multiply it by our terminal action right here. And this one fair? It is a little confusing because there's a lot of notation, so you end up needing to take whatever you have there. It is a bit mathy this time, full disclosure. All right. So our terminal action, again, is 1 plus. If it's a negative value, it'll just be minus. And then you have this here. What is this? This is 18. I hear that's an important number. It also happens to be the total number of mass boundaries that we're working with. Times 7, our breaking scale symmetry, times 5, the n number of dimensional ingredients we have, times space, charge, mass, temperature. And that's divided by the hyperbolic sign raised to the 6. That goes in there 3 times. That's kind of interesting. Times the, what the heck is this? This is the real point of the fixed point of the hyperbolic cotangent. What the heck is that? Well, real fixed. Oh, not fizz. She comes usually on Thursdays. Fixed point of the hyperbolic cotangent. Boom. All right. No. I want to go to. That's why we can't have nice legs. Real. There we go. The hyperbolic cotangent. Oh, and math. Oh, look. Oh, that's actually very interesting. I saw some of those in maybe a completely other context. All right. It's defined as cotangent hyperbolic of z. Basically, you could express that as parentheses x plus iy, yada yada, is equal to e raised to the z plus e raised to the minus z, all over e raised to the z minus e minus z. And it equals this stuff and things here. All right, comes out to be this value. Okay, fascinating. So, oh yeah, I use this for a screenshot. Moving right along, the electron mass. To be fair, these should be updated anytime because we did the 2019 update, and they usually do it every 4 years, so we're waiting on you good folks at CoData. I know you're going to do an amazing job because we can, and it's important. But these little values we're looking for. So basically, 9.109383701.5 error bars of 28 times 10 to the negative 31 kilograms. That's really freaking small. But, hey, Kali. No, thank you. Okay, yes. Apparently, I was totally muted before. These things happen. If I'm less lazy than I expect, then I might update that. So what are we looking for here? Here's our friend again. Links to the stuff and things in the doobly-doo. Is our friend the hyperbolic vortex equation. Claim is we have our 1 over x plus x cubed divided by 2 pi, so like a big twist on a volumetric area, or volume. So equal to I raised to the I raised to the negative pi divided by 2. We require a lambda. Lambda happens to be the magnitude of the Planck mass. So 2.17 times 10 to the negative 8, yada, yada, yada. I have a list of how to geometrically derive them in a playlist. The first answer when you square it, claim is you get the fine structure constant. Cool. That's in plenty of other videos on this channel. But our construction, to get the mass of the electron, it's a lot of characters because I wanted to use some more digits. I just didn't feel like deleting a bunch of digits. So basically my laziness is the primary action is right here. So, all right. You have those 4 Giesecke constants. You can just write that into Wolfram alpha. So it's like, yep, 4 Giesecke constants. The magnitude of the Planck mass. And then we raise it to the 4th power. 4 Giesecke constants. And then 4 Planck masses. That's pretty neat. And we need our terminal action. How the heck do we get this thing here? Okay. So the terminal action part 1 in the doobly-doo. It's going to be this. It's that 1 and multiply it by 18, 7 times 5, 35, yada, yada, sine of 6. That's the value of that hyperbolic cotangent right there. So, boom. You can get that in there. Oh. Okay. So we have that, and then we need our jeux. I didn't even go over the jeux. What a terrible explainer I am. Because this is basically how the poster is encoded right now. We're looking at the jeux in the terminal action to see if we can notice a particular grouping. Because it is very interesting, and Thad also spent about 5 months doing this and finished literally a day or two before the most recent conference. So our jeu 1 cubed times jeu 3 and jeu 4 cubed. This is our inversion boundary right here. It's the Planck mass times the Planck length over the Planck charge squared. So that gives us 10 to the negative 7 again. Videos on that on this channel. It comes out to be precisely a 1 ampere. It's or 1 amp. Very interesting. Electricity seems to be zipping around, and we'll leave that for more detailed discussion another time. So, for brevity's sake, okay, we have our jeux over here. Yeah. Okay, and I think this was too many. Yep, too many characters. So I had to break it up. So we have that part, our part with the jeux, and that 10 to the negative 7, which you could express as 1 over 10 to the 7, is right here. So jeu 1 cubed, jeu 2, I believe that's actually 4, and then that's 3, because it pops up in different order for me. But if it's commutative, we should be okay. All right, those are cubed. Gives us this number here. All right, so We plug in that number with our other part. Okay. We have our crazy big number there because I didn't delete them or any decimal points. This is our total terminal action. Our total terminal action is this. We go back and we plug it in to this primary action here, the 4 Giesking constants times our dimensional boundaries raised to the 4th. So kind of a 1-to-1 match, if you would. And we get this number here. Let's take a look at this number. What is the number we're looking for, our friends at Codata? All right. The number we're looking for is 9.109. All right. 9.109. 383. 383. 7015. 7015. Well, that's the 1 point. Oh, it keeps on going on. Times 10 to the negative 31 kilograms. It's 10 to the negative 31. My friends, this appears to be a geometric derivation of the mass of the electron. Precisely to all the digits that we have. I think that's pretty neat. And it also seems to go into a particular method of grouping that maybe folks haven't checked out before. So again, we got the links to the do-we-do. I'm going to do actually probably a lecture at some point, actually just trying to explain all the stuff and things that I know, because I realize if you're jumping in at random points, like, what the heck is this dude saying? Hey, I'm competitive. Good to see you, my friend. I realize this is a lot. I'm also a crazy person that literally joined a monastery after the past 2.5 years doing this because I think it's actually worthwhile, and I think there's something here. It's also got 2 or 3 more predictions than string theory. So take that for what it's worth. That's all I got for right now. So, hey, peace out, everybody. Take care of yourselves. It's a crazy world out there, but I'm betting on karma. Lord knows. I think we could use some right now. Hey, Rick. Peace out, everybody. We'll catch you all later.